class. And this is our official start for CS 143, Big Data for today. Yeah, so today we're going to, well, first of all, hopefully you've printed out some of the cheat sheets that I had before. They're listed on the week 0 folder for the course. There's never going to be tests or anything on any of the material in these cheat sheets. They're just a handy reference for you. Today in class, we'll be going through a super quick sort of lightning speed tutorial of using the command line, using Vim, why it's, what are the situations in this class where both of those things are going to come really handy, be really important. And but we'll really be focusing on Git and using Git and how all of that integrates together. Yeah, at any point in the class, so probably going to go a little bit quicker today than I necessarily normally would in most classes. So definitely at any point today, feel free to interrupt me and ask questions. But also don't feel like you need to 100% understand everything that, like every little character that gets typed on my keyboard. That the real sort of mindset that you should be thinking in is like getting the big picture idea of how I think about these tools and why I use them in different situations. And then for you all, when you're actually going through the lab and the homework assignment this week, that'll be when you actually get the like nitty-gritty detailed understanding of all of these things. Any questions about any of that? Okay, so one last quick announcement. Actually, I'll share my screen first. There we go. And then last quick announcement is under the issues in the, oops. Well, so yeah, real quick. So the lecture recordings, again, all posted on YouTube. They'll all be on this link right here. But what I really wanted to do was the lab time survey. That it seemed like Fridays 10 to 11 was, I know not everybody's available that time, but that's about the best time that there was. So that's when I'll have sort of the lab times for this class. They'll be on this same Zoom link, and it'll be a very informal sort of session where yeah, feel free not to have done any of the lab work before then and do it all during the Zoom session, and you can ask more detailed questions then that maybe we don't have time for in class. But again, it's also not required, it's just available there if you'd like that. Any questions about anything like admin-wise in class before we get started with the command line and Vim and Git?
Professor?
Yes.
For the lab, is it just going to be the same link they use for class?
Yeah, great question. So for everything that I'm doing this semester is all on this same Zoom link. So class sessions, lab, office hours. If we ever set up one-on-one appointments, it'll always be through that same Zoom link.
Okay, thank you.
Great question. Any other admin sort of questions? Okay, then we're going to get started with some bash. So I'm going to switch over to this window right here. And generally when I am programming, when I'm working, I do all of my work in the command line, and I usually have two windows open up at once. And you're welcome to do whatever works for you, but I think this is a great setup that works pretty well for a lot of people. And right now I'm logged in on the right-hand side on the Lambda server, and on the left-hand side, I'm just logged in on my laptop. And so the first thing I'm going to do is log in on the Lambda server on the left-hand side. And the first very useful shortcut in the terminal that you should know is Control-R. So I'm going to first type it out like this, CTRL-R. And if you press Control-R, it lets you search through your entire history of things that you've typed into the shell before. And so this SSH command, in order to log into the Lambda server, is a really annoying one to remember because it's got that IP address with all those digits in there and that port number. And if I have to type it out manually, I can never do it. So it's much easier to search your history. And after you press Control-R, it brings up this little prompt right here. And then you can just start typing part of a command, and it will search what is the most similar command to the thing that you've typed in before. So do SSH, and here is the most recent SSH command that I've done before. I'll be logging in today as user test instead of my normal account, just to help illustrate a couple things. And then I'll hit enter, and it'll ask me for my password, and I'll log in, and there we go. This part over here is called the prompt in the shell. So anytime you see things in the tutorials, labs, homeworks that end in a $, that is something that should be typed into the terminal at the prompt. That this over here is called the prompt. And so some of the most useful commands are ls, lists all of the files in your current directory. This user account currently has nothing in their current directory, except if you do the ls space -a command, -a stands for all, list everything, all the things in your current directory. And so you notice now there's a lot of files that start with dots, these periods. And these are called dot files in Linux, so dot files. As we're going through this too, on the right-hand side, I'm gonna take some notes when I type things out. So dot files start with a dot, and then these notes will be uploaded into the GitHub repository afterward too. So again, you don't need to feel like you're having to type along everything that I type as we go. These dot files, what's special about them is that they control your configuration settings on the terminal. You're welcome to modify them however you'd like. Let's see, so it looks like there's a message in chat that you can't see the first line of my terminal. Is that on both sides of the screen?
I think it might be, is your like little zoom control bar at the top up there maybe?
That's blocking for you guys. Okay, let's see. Is that better on the right-hand side now? You can see what I've typed over there. Great. There's nothing important on the left-hand side. I'll try to, in the future, avoid that. Thanks for pointing that out. Yeah, in general too, for lectures, feel free to type things in the chat or things like that too. That's totally fine to interrupt me and let me know if fonts are too small or you can't see something, anything along those lines, or if you just have a question, feel free to interrupt me. Yeah, so these files that start with a dot, they're dot files, hidden files, by default not displayed unless you do this -a flag in ls, and then it displays them. Right now we're in my home folder. This tilde right here represents my home folder, and all of the dot files, all of the hidden files in your home folder represent configuration files for different programs. And so vimrc and bashrc are the two that'll be the most important for this class. And in the lab, it has instructions on how you can adjust these so that your terminal settings match mine, and then it'll be, I think they're pretty good defaults for the terminal. And you'll be able to see everything will be exactly the same as on my screen if you do that, but you're also welcome to customize it to whatever is good for you. So this shell here, something that's maybe not entirely obvious is not only can you type commands, but it's actually a full-fledged programming language called the Bash programming language. So Lambda server shell uses Bash programming language. And just like any programming language, there are variables in Bash. And so one of those variables is home. And let's see, first, so there's this command echo. Echo just prints out whatever you pass over here onto the screen. If I do echo and then $, HOME like this, it prints out the contents of this home variable. So in Bash, anytime you're accessing a variable, you put a $sign in front of the variable. So here, this is my home folder, and so this $home outputs this. Another very important variable, which we'll be talking about a lot in class, but we don't need to know the details about now, is this path variable. And another one is this $PS1 variable. PS1, what it stands for is, actually I don't know what it stands for, but what it does is it controls how your prompt over here is being displayed. So often in class, I will change my PS1 variable so that it is much smaller, and so that we'll be able to see more things in class. And so I'm going to do that right now. I'm going to change this PS1 variable, and the way to do that, export PS1 equals, and then what I want the contents of the PS1 variable to be. And in this case, I'm going to make the contents just be a $sign and a space. And I'll hit enter. And this, again, this PS1 variable controls what is displayed over here. You can see that there's a potentially relatively complicated syntax for how you can format these things differently. But yeah, so now I've made it just this single prompt, so we'll have more room to be able to see what's going on with this command line. We're getting to the end of the screen down here, so I'm going to want to reset my terminal and clear it off so that everything appears at the top again, but then I'll hit enter up here so that the top line's not blocked.
What if you want to reverse the PS1 back to how it was?
Great question. So the question is, what if I want to reverse the PS1 back to how it was? You can redo this this PS1 variable as many times as you want. So let's change it to this now. Let's change it back to this. That there's no way to specifically undo to get back to what it was before. But this is only a temporary modification. Anytime you do export and then a variable name, that only affects your currently running program and any programs, we say any programs spawned by the currently running program. If you want to actually reset it, go back, you can exit your terminal with the exit command. Now I'm back on my laptop. Now I'm going to rerun the SSH command. But instead of doing the Control-R to find the SSH command, I know that the previous command I ran on my laptop was this SSH command, and you can use the up and down arrows in your bash shell to go up to previous commands. So I'm pressing the up key right now to get back to my previous SSH command, hit enter, and now I will log in again. And now I'm back to my, my previous PS1 prompt variable that I had right here. A little bit more detail about what's going on technically is that every time you log into a new bash session, which is what happens when you do SSH, this .bash.rc file automatically gets run for you. And if we were to open up this bash.rc file, so vim.bash.rc, and I'm going to search for PS1. In Vim, the way that you search is you press the / button while you're in normal mode, and then you can search for whatever you want. And here it's actually setting what the value of the PS1 is. So this command gets run at the very beginning every time you log in, and that's what sets the prompt for you. So I'm going to quit now, :Q, back to the terminal right here. Great question. Any other questions so far?
I have a question. So before the PS1, you said that changes like what the stuff on the left-hand side says, right? Like the Lambda server part.
Yeah.
So before, when we like did echo PS1, should it have said like Lambda server instead of all that like random letters?
Yeah, it's a great question. So when I do echo $PS1 right here, there's all of this very confusing looking stuff going on here. There's too much details for us to talk exactly about what all this means. But the high level idea is that this PS1 variable, it's almost got like its whole programming language, its own type of programming language inside of it. And so this Lambda server string right here, it's not hard coded into it. Instead, it's using the name of whatever computer I happen to be logged into. So before, you saw when I was on my laptop, the name of my laptop is cleverly called just laptop. And here we go. You can see that the PS1 variable for both my, when I'm logged into the Lambda server and when I'm logged into laptop, they're both the same value of PS1. And this weird syntax is causing it to display differently. There's no need for you to understand any of this weird syntax, but if you're motivated to create some cool looking prompt for yourself, you're able to look that up. The main takeaway is just that if you have a variable, the way that you set that variable is you do export, then the name of the variable, and then the contents of the variable. So that's how I can set that PS1 variable, which happens to control this thing. I can create my own variables by saying export my variable equals hello world, like that. And now if I do echo my variable, it has the contents of hello world. And that's the important thing, that's just how you assign variables, and that's how you access variables. There's a good question in the chat about, is there a reason that it's called PS1? And there is a reason, but the reason for all of the things involving Unix are incredibly arcane and go back to architectural decisions made in the early 1970s. So PS, I forget exactly what that stands for, but there are 5 different PS variables, 1, 2, 3, 4, 5, and they all control slightly different things about how your terminal is displayed. But on every system, whether you're on Linux or Mac or Solaris or some random thing that, I don't know, that's invented 50 years from now, PS1 will always be the thing that controls this prompt right here. Great question so far. Any other questions? Okay, so the, let's see, we'll come back to variables here in a little bit. So, let's see. Yeah, so the comment in, so PS standing for PowerShell. PowerShell is a Windows version of the command line, and this PS I don't think stands for PowerShell, because PowerShell is a very recent thing. This PS existed like 40 or 50 years ago. I think the P stands for POSIX and the S stands for, I'm not sure what. But I could be wrong. Yeah, we'll come back to variables here in a little bit, but what I want to do first is talk some about Git. So Git is it's a command line tool, and it's very easy to confuse Git with GitHub. GitHub is a web page, Git is the command line tool. And so down here on my command line, if I type Git like this and hit enter, I get lots of very detailed instructions about how to use Git. A lot of the very complicated tool, but also a very powerful and useful tool. So we'll give some of the basics today of using Git. These are the basics that you'll need to complete the lab and the homework assignment. But throughout the course, we'll see yeah, a lot more detailed things with Git. All of these things too are things that like Git is not something that will ever be, say, tested. It won't be in midterms or finals in this class. It's just things that you'll want to know to actually be able to complete the assignments. And it's also sort of the, I'd say the most important tool to know for future jobs, but also the tool that is least taught in computer science curriculums or data science curriculums for future jobs. And so when I talk to people out in industry, one of the things that they're always saying is that we use Git every day, thousands of times a day, but students, our new hires, have no idea how to use Git. And so that's one of the reasons why we're incorporating it into this class, is that it's just that widely used in industry. So as our example of how to use Git, what we're going to do, I'm going to switch back over to the web page for a second, and we'll come up here. And I want to look at week 00. And we scroll down here and we'll see that some new stuff has been added to our web page for this week. I just added this right before class. And so famous programmers, Linus Torvalds, the creator of the Linux operating system. So Linux is a sort of a derivative of Unix, where Unix was what that video that you watched before class. And the name Linux is just Linus's name right here, but everything related to Unix has to have an X in it, so he decided to replace the S in his name with an X, and that's where we get the name Linux. In this class, one of the advantages of having our class hosted on GitHub is that you all will be able to propose changes to our course, whether it's like big picture syllabus changes or small typo changes. And here we can see that we have a lot of typos that apparently, I was a very bad typist this morning and made lots of typos here. And so what we're going to do is we're going to go through the process of what you have to do from your perspective to propose a change to the course or to any GitHub project and fix a typo or whatever else it might be. The particular cheat sheet that we'll be following for the next half hour or so is this one right here. And we'll go through exactly what all of these steps mean and how you repeat them for yourself. So the first thing to know is that the project that I'm currently looking at, this is what we call the Upstream Project in Git terminology. So it's what I have in this bubble right here labeled as Upstream. And we want to make a change to the Upstream repository. All of these projects, when a project is put inside of a Git, when it is managed by Git, we call that project a repository, where the source code is in a Git repository. And so in here, in this bubble right here, is a URL to a GitHub repository, or a Git repository hosted on GitHub. And currently, I'm actually logged in not as my standard GitHub user account, but I'm logged in as this account right here, example student. And so because I don't own this repository, I'm not allowed to just go in and make changes. It's not like Wikipedia where anybody can make any change they want. Instead, you propose a change and the owner, the maintainer of the repository has to accept that proposal. Those proposed changes in Git terminology are called pull requests. And so what we're going to do is we're going to create a pull request that fixes these typos right here. The first step in order to do that is going to happen on the web page. That this step 1 right here is fork, and we know it's on the web page and not the terminal because it's going from a cloud to a cloud, going from a URL to a URL. And so at the very top of the repository up here, there's this fork button. And so I'm going to press that, and it'll take a second. And what forking does is it just duplicates the repository. So now I have my own version of this repository. You can see in the top left up here, I know that I'm on a forked repository because it now has my username up here / the repository name, and it says forked from the original location of the repository. If we were to scroll down, then we'd see that the contents of this web page is otherwise exactly the same as the contents of the class repository. Yeah, so up here, I know this is the original repository because it has the owner's username up here, Mike Isbicki, and it does not below say forked from, it just has nothing. But if I go forward now I know this is the forked repository because it has this right here. And then the URL up here is going to be different. It's going to have your username instead of the maintainer's username. And now I'm going to copy that. And coming over here to the cheat sheet, so that was the fork step, step 1. The next step here is step 2, Git clone. I have to take my version of the repository that's hosted on GitHub and clone it onto the Lambda server. So I'm going to go back to the command line. Let's clear this screen. And I'm going to type ls again just to remind us that there is currently nothing in this folder right here. And then the command is git clone, and then the URL of the repository that I want to clone. And it's important that I'm cloning the forked version of the repository and not the original version of the repository. Enter. Takes a second to clone it down, download it. It has to do some decompression and things. And now if I type ls, it has this this new folder here that contains all the files from the class repository or whatever project you cloned. Yes.
What would happen if you tried to pull in the original one and not the cloned, or not the forked one?
It's a great question. And yeah, so the question is here, what I did was I cloned my project, and the question is what would happen if I cloned the original project? And the answer is that at this point, nothing bad would happen. So I'll go ahead and illustrate that. We'll make a temporary folder. mkdir is how you make a folder. I'll call it TMP. So now there's this TMP folder. Go into the TMP folder. I'm going to press the up arrow to get back to my git clone command. And as I'm going left and right, you notice that my cursor is jumping quite a bit, like jumping one word at the time. If you hold down Control as you hit the left and right arrow keys, it will jump, so you don't have to press left and right 1,000 times. You can press it just 3 or 4 times, however many words. And I'll replace the username and the URL with the source username, the Upstream username, and hit Enter. And everything downloaded perfectly fine right now. The reason is that everybody has read access to this repository up here. And so anybody can clone it, anybody can read this information, but we do not have write access to this repository. So after I make my changes and I try to upload those changes, that's when we'll get the error message. This repository down here, the origin repository, the repository that you forked from the upstream repository, that one you have both read and write privileges to. And so now when you try to upload it, it'll be successful. Yeah, one of the really confusing things about Git when you're first learning it, and this was confusing for me, it's confusing for everybody, there's so much going on with Git. But one of the things that's really confusing is that if you make a mistake at one point in your flow, so this is the very beginning part, if instead of cloning from the origin, if we clone from upstream, we're not going to get an error message at the point we make a mistake. We're going to get an error message down here on this step 4. And so at the very beginning, it can be very frustrating trying to figure out where did I make a mistake, because you don't get the error message at the point you made a mistake. Great question. Any other questions so far? Also, great job, everybody, for interrupting me and asking questions. I appreciate that. Okay, so right now, well, let's see. Right now, I'm going to introduce the Pwd command on the terminal. Pwd stands for print working directory, and the working directory is the place where you're currently located. It's sometimes called the current directory by some people. That's a kind of a Windows terminology. In the Linux world, the working directory is always the directory that you're currently working with. And so I'm currently in this folder right here. And so I type ls, and this folder right here is the one that I downloaded from the wrong URL. And I want to get back to the one that is the correct URL. And there's multiple ways to do that. In general, in the shell, there's lots of ways to accomplish the same task. I could do cd. So cd stands for change directory. And then the name of the folder that I want it to go to, like this. Instead of hitting enter now, I'm going to press Control C so that that command doesn't actually run. on the terminal, anytime you see an up caret like this, that means that the person pressed Control and then whatever the next letter is right here. So this is Control C anytime you see that. Another thing that I could have done is if I do cd by itself with no arguments at all, this will take me to my home folder. My home folder is just /home/user_test. So this would also do the same exact thing. And another thing that I could do is cd space ... like this. And ... always takes you to your parent folder. So right now I'm in this folder right here. The parent folder is /home/user_test. So cd ... would take me to my previous right here. And I do pwd, and that's where I'm at. Now I do ls, and we have our cmc -csci 143, and that's where we want to go inside of. If you notice, after I type, I'll be doing this a lot throughout the course. After I type just a couple letters of a file name, I am lazy, and so I don't want to type out the whole file name. I am also a puny human, prone to making lots of mistakes with my fingers, typing things wrong. So I try to avoid typing as much as possible. And the terminals all support something called tab completion, where if you press the tab button, it will complete what you're trying to type. And if there's only one possible option, it will be able to do that for you perfectly. So I just type, in this case, I can just do C and then tab, and it finishes it out for me. And now here is my working directory, ls. Here's all the contents of the working directory. And if we were to look back at the web page, and we'll look, yeah, here we are at the root, we'll see that these files listed up here are the same as these files down here. There's one tiny exception to that, and that is up here. You can see that there are some of these hidden files, these dot files starting with dot. And so those files did not get listed. Right here, you can see that on the web page, there was a file .gitignore and .getmodules. Down here, those files do not appear, but if I do ls-a, then they do appear. Here is my .gitignore and .getmodules files. Yeah, we'll talk later about what those files do. They're internal to how Git works, but for this point, we could ignore what they are. You'll also see, though, that there is this file, or it's actually a folder, .git, and this is where Git internally stores a bunch of information about the repository. And so this is something that will always be in every Git repository that you have, but you never want to manually edit it. Every time you run a Git command, like this Git Clone command, it will modify the contents of this folder for you, and you never want to manually modify this. Okay, so over here, going back to the web page, the thing that we wanted to change was in this week 0 folder, and it's in the readme.md file. All of the contents that just get displayed down here come from the readme.md file. And in particular, we wanted to fix this typo right here. So I'm going to come back to the terminal, and I will cd into the week 00 folder like this. ls, here's the readme.md file that I want to edit. And so I'll do vim readme.md in order to open it up and edit it. MD stands for Markdown. Markdown is a common language for creating these sort of really basic README files, and it'll get converted into HTML and displayed on very nicely by GitHub. But the contents of this are not HTML. They're a little bit more plain. So I'm in Vim. I could use my HJKNL to try to move my cursor all the way down to wherever it is that I'm looking for. But instead, I'm going to be a little bit more efficient and search the file for what it is that I'm looking for. And so again, in Vim, it's the / key, the / is how you search. And so down here, I'm now in the search prompt, and it was E♯V was the thing that I remembered about this line that I wanted to search for, and there it is. Yeah, so the way, let's see, the way that I'm going to fix this is I will so move my cursor over to the left, and now in Vim, you can press Shift R, the uppercase R, to go into replace mode. You know I'm in replace mode because bottom left it says replace, and now I can just type over all of this, oops, with the correct capitalizations like that. And colon, whoops, and colon W, we'll save that. And colon W quit. Right now, when I've edited this file, I only edited it on the local machine, and I did not edit it on the remote GitHub server. If I open this file again, and now come down here, you can see that the file has changed on the local server. But if I go back over here to my GitHub repository, you can see that I am in the example student repository right now. But when I refresh it, it still has all of these same typos right here. And so what I have to do is I have to what's called commit the changes and upload the changes. In Git, anytime you create a commit is like one logical change, one unit of change. And there's a lot of philosophies about like how big or how small one of these commits should be. But it's always exactly a two-step process. You run, I'll type it in on the left over here. So creating a commit, 2 steps. The first one is always git add, and the second one is always git commit. On the cheat sheet, we have this, there's 3 lines right here, Vim file, so that's what we did first to edit the file, and there's the git add and git commit. Those are the separate parts, and these things only affect what's going on the Lambda server. So back over here, back in the terminal, instead of starting off with git add, I'm going to run a command called git status. Git status tells me the current state of my Git repository and what files have been modified and need to be committed. So this file right here, readme.md, is in red, saying it needs to be committed because you've made some changes to it. And so I can do git add readme.md, and then if I do git status again, now it's in green right here because I have added it. This area of stuff that's in green, under where it says changes to be committed, is sometimes called the staging area in Git. So you'll hear people use that word a lot. After the git add command comes the git commit command. So git commit. And so add, you can add multiple files at a time. I could rerun this add command again, but I'm going to just do git commit for now and hit enter. And you notice that the very first time I do this, it comes up with these error messages right here saying you need to tell Git who you are. And so I'll quickly do that. Like that. And now I will have to rerun my git commit command. So notice I'm not retyping that in, I'm using the up arrows to go back to it, git commit. And when I run git commit, it opens up a Vim editor window for me. What I type in to the editor window here is called the commit message, and it's just a short summary of the changes that I've made. So I will type it out as fixed typos. All of the things in this that start with a hashtag are comments. They will not be part of this message, and they'll just get deleted. It's very common for these commit messages that you're creating. The standard for Git messages or Git commit messages is that they should be in the second person. So they should be like commands, like I'm issuing a command right now to this computer to fix those typos. And :WQ to save and quit. And you get this short summary telling you like what's actually changed. There was one file changed, one line inserted, one line deleted. So because I modified one line, that's the same as deleting it and adding a line. Let's go back to the cheat sheet. That's everything that happens on the Lambda server right here, vim add file, git add file, git commit. And now from the Lambda server, we need to update the things on GitHub down over here. And so the command for that is git push origin master. What this origin is the name of the actual place that you're trying to send it to. So origin always refers to the location where you cloned from. So because I cloned from this URL right here, that's where I'm pushing it to. And then master is what's called a branch in Git. We'll see in other situations, you can have different things right here besides master, but it's very common to, that on a repository, the main branch is called master. So that's why I have origin master written there. And so I'm gonna type that right here, git push origin master, and hit enter. And you'll see that I get an error message down here. So this error message says refspec master. So this part right here is technically referred to as a reference specification or a ref spec. And it says it does not match anything. On my web page, so I'll come back over here, and scroll up to the top. This right here is the name of the branch, the name of the ref spec that I'm working with. And in this case, there is no master branch. Master is sort of the default. Most repositories have a master branch, but this repository does not. And instead, what I want to be editing is 2021-2021 spring. And so I'll come back here, up arrow to get back to my previous command, delete master, type 2021 spring, hit enter, and now I have to type in my login credentials. So see if I remember what they are for this account. Oh, I typed in the wrong username. So my login credentials for GitHub are different than they are for the Lambda server. That's totally okay. But the username that I type in is my GitHub username here, not my Lambda server username. Example, student. And then again, you'll notice as I'm typing in the password right here, you don't get to see what the password is, but it knows that it's typing things. And then you'll get some, a bunch of output message about progress is making and uploading and things like that. I'm gonna come back over here, hit refresh, and scroll down now to where the typo was, and now it has been fixed. Let's see, we just did a lot of steps. Are there any questions about any of those steps about how to go about fixing a typo on your own repository? Okay. The last step is, so right now I've done 1, 2, 3, and 4. The last step is this going from your origin repository up to the upstream repository, and that's issuing a pull request. Step 5. This is something that happens on the web page, not through the command line, and it's this button right here, pull request. GitHub changes their interface reasonably, so I sometimes forget where it is, but I'm glad I found it on the first try real quick right here. I'll press pull request, and it gives me a summary of all of the changes that I've made to the different files. So here, this what we're looking at right here is called a diff, a DIFF, standing for the difference between two files. And it shows a short summary of, in red, the lines that were deleted, and in green, the lines that were added, which makes it really easy for the person who is the maintainer of the Upstream repository to look at your pull request and see what changes you made and whether they're good changes or bad that they want to incorporate. So green, create pull request. I can add another little message right here if I want to. We'll just go straight to creating the pull request. And now there's this pull request right here, fixing the typos. So currently I'm still logged in as my example student account. I'm going to switch screens now. And now I'm logged in as my actual Git account as Mike Isbicki. And we'll refresh this. Ooh, the CSS got jumbled there. And now we can see there's a pull request over here that is waiting for me. We'll also come down here and see that in the original repository, the Mike Isbicki repository, the Upstream repository, these changes have not taken effect. But if I click on pull request and then click on the fix typos, and then I can come down here and press this merge pull request. And now all of those changes are have been incorporated. Let's go back to this week 00. Week 00, scroll down, and we'll see that those changes have in fact been incorporated. Are there any questions about that overall Git pull or pull request process?
I have a question, but it's not really, it's somewhat related to this. I was following through one of your tutorials and it was going through linting your code, and I was wondering if there's any way that from a Lambda server you can open something up in VS Code. And I know you said no VS Code, but I don't know how to count lines otherwise unless there's like a part that I'm missing.
When you say count lines, I'm not sure what you mean by count lines.
Like when we lint, it tells us which line has like an extra white space or needs.
Yes. So let's go to the terminal here for a second and type ls and this readme.md file. And I'm going to go down here to this line right here. And in Vim, depending on how your Vim settings are, there's it shows all of these line numbers here to the left. The way to, the command in Vim to cause it to show line numbers or hide line numbers is you type colon and then, let's see, I forget, so I'm gonna open up my vimrc file. The vimrc file is the file that Vim loads on startup, and it has all the commands that get loaded on startup. So tilde is my home folder /.vimrc. And search for something beginning with no, because that's what the numbers are. Set. Somewhere. Well, I forget the command, what it exactly is, but on the lab, it does have instructions for downloading my vimrc file, and if you do that, then you'll get these numbers applied as well. So that's the right way to find the line numbers for things.
Okay, that makes sense. Thank you.
You're welcome.
I also have a question related to Git.
Mm-hmm.
So what if the upstream repository gets updated and you want your forked repository to get updated and your fork cloned repository on the Lambda server, how does that work?
Great question. And this is exactly what we're going to talk about next. And this is the part where, Git can start to get confusing, and if you've used Git before, then you've probably seen this sort of like general pull request procedure. But you've also probably seen a lot of situations where things can go wrong for various reasons. And if you don't have like a fully deep internalized understanding of what's going on with Git, it can be very difficult to debug what's going wrong. So this particular situation that I think was that Pwd who was asking about, what he suggested, or the problem that he suggested, is that what happens if the upstream repository has changed somehow. So here, I'm going to change the, just change the README file, and I'll use the web interface for making this change. Oh, and actually right now I'm logged in as the example, so I'm going to switch over. There we go. Now I'm logged in as my account, and I'm on the README for week 0. I'm going to use the web interface to make an edit. On this class, I am asking you not to use the web interface to make any edits to any repositories, to always go through the procedure of using Vim and doing it on your on the Lambda server, just to help develop the muscle memory for like how to do things sort of in the most correct way. What this web interface is doing is it's actually doing all of those same terminal commands just sort of under the hood. But yeah, just to illustrate how it works in class right now, I'll use the web interface. And what I'm going to do is I'm going to add a new bullet point right here. So GitHub immediately after Git. And then I'll commit my changes, commit changes right here. And now here on the upstream repository, the Mike is Bicky repository, it contains this bullet point number 8 saying GitHub. But if I come over to the origin repository, sometimes called the downstream repository, and look at the README file, whoops, that's still under Mike is Bicky. So up here it's Mike is Bicky, so it has this GitHub down here, but if I change it to example student, so the downstream repository, it does not have GitHub right here. And so the question is, how do we update our downstream repository from our upstream repository? And this is, let's see, I'll walk through the steps over here on the left. It's both relatively simple and potentially very confusing at the same time, because it's again one of those situations where if things don't happen in the exact right orders, then you'll get error messages at the wrong spot that won't be very helpful, telling you exactly what step you had the mistake on. So when say the upstream repo is ahead of origin, also known as the downstream repo, how do you update it? And the first step is git remote add origin. So anytime you have a Git repository on your local computer, so you're on a terminal and you're running Git commands, and you want your Git repository that's on your terminal to interact with a Git repository that is hosted in the cloud somewhere, whether it's on GitHub or an internal company server or Bitbucket or any of these other services, you always have to tell your internal Git repository about these other locations. And that's what the git remote add does. Tells your repository, your local version of Git, about these remote sources. So Git Clone automatically creates this origin remote for you, and we need to create the upstream remote. So it'll be git remote add upstream, git remote add upstream, and then the URL of this upstream repository. So back over here, this is the URL of the downstream or the origin repository. I'm going to click right here to get to the upstream repository, copy that URL, come back over here and paste it here. And so we have git remote add upstream, and now this is the original source. Hit enter. And now I can I don't have write access to upstream, but I do have read access from upstream. And I can say git pull upstream, and then the name of the branch that I'm working with, in this case 2021 spring. And now we can see that it made that change to week 00 README right here, added one line. But this again is only local on my current Git repository that's located on the Lambda server. It's not yet on GitHub. In order to make it on GitHub, I now have to do git, let's see, maybe updating over here. So you start with the git remote add upstream. And let me spell upstream correctly. And then it's git pull upstream branch name. So I just did 2021 spring. And then it's git push origin branch name. So when I'm pulling, when I'm downloading from the upstream repository. But then when I'm pushing, when I'm uploading to the origin repository. So in the picture form, I'm downloading from upstream, take upstream onto the Lambda server, and then I will be pushing from Lambda to the origin over here. Back over here, git push origin 2021 spring, hit enter, and the credentials. There we go. And now I come back over to the web page. I'm need to go to the example student one. Example student. And then week 0, come down here, and now I see that GitHub has been added right here. So the summary in picture form is that when you have the upstream and the origin both located on GitHub, you can create your origin from the fork command, but you cannot through GitHub go directly from the upstream to the origin. Instead, you have to git pull from upstream onto the Lambda server and then git push from the Lambda server onto the origin. Great question that's gonna come up a lot in this class, how you update your origin repository from upstream. Are there any other questions about what we've seen so far?
Yeah, so can we go back to the command that you used, like the other tab? So is upstream a part of the command, or is that just what you named the repository?
That's a great question. So here in this, the actual command itself is just git remote add, and then upstream here is just a name that I'm assigning to this remote location. So it's traditional for the vast majority of projects only have sort of 2 remotes that they're working with, the origin, your fork, and the upstream is the original one. And so it's traditional to call this one upstream and this one origin. But there are some like very complicated projects like say the Linux kernel, millions of lines of source, Microsoft Windows contained in Git repository, also millions of lines of source. All of these really big things will have multiple different of these remote URLs, and they can be named whatever. So it's just tradition that this is called upstream and origin, and down here, you could name this whatever you wanted as long as you're consistent. Whatever you put here has to be put here.
Cool, that makes sense.
Similarly, origin is just a name. It's the default name when you run Git Clone, what's automatically created, but any name would work. Great questions. Any other questions so far? Let's see, I want to just double checking. I want to make sure that I'm always respecting our time for class every day, and the time slots have changed, but I think we're going from 9:15 to 10:30, so we have about 10 more minutes of class. If ever I do start running late or anything, feel free to interrupt me and let me know so that I don't run over. But I want to show a little bit more like, so like in this first part, we kind of talked about the mechanics of Git and just like, here's how you get these tasks done. I want to talk a little bit now about some of the why of Git and some of the cool features of Git that maybe even some of you have used it before are not 100% familiar with, and we'll see some cool stuff. So basically what I want to do is, so if we go back over here to this, this web page, this is kind of like, I'm going to consider all of this text right here to be a bug in my README file that I've decided that I don't want to have it anymore, and I want to figure out like who is the person who actually added this to the class web page. And for this repository, it's small. I'm the only maintainer, so I already know who did it. But if you're working on like a big project, then all the time you come up with code and you want to know, oh, who actually wrote this code, so you can go talk to them and figure out like what they were thinking when they were writing it. And in Git, there's a very famous command called git blame, which lets you figure out who to blame for every line of code in your file. So git blame tells you who wrote what line in a file. And I want to figure out who should I blame for this Linus Torvalds being added into our repository. And so what I'm going to do is git blame and then the name of this file right here, readme.md. And it opens up this screen with every line of the file and some information about that line. I'm going to shift the window over a little bit so that it's a little bit easier to see things, even though we can't see the notes anymore. And so you can see that here is the, on the very farmost right side, that's the line-by-line contents of the file. And then on the left-hand side over here, this is what's called the commit hash. This is like the name of the commit. We'll be seeing that in detail later. This is the name of the person who created the commit, and this is the time that the commit was added at. And so again, I want to find that location where all that stuff was added, and so I'm going to be using the / command to do search. We're not currently in Vim, but / is a general Unix thing that if you're in a command line program and it supports search, it's almost certainly done by pressing / because / is a so ingrained in Unix culture. A lot of actual like Windows programs have started using / as search as well. And Firefox, at least the version I have, / is the default key binding for doing search on a web page in Firefox. So / and then EVER, hit enter. And so here is the line of, or the lines of the files that were added by this one commit. It says famous programmers, Linus Torvalds, and then this image. And if we look over here, we can see who actually made those commits. So most of this file was written by me, but we can see that Linus Torvalds actually came in here, and he's the guy who came in and added those commits. He added himself as the famous programmer. And here's the commit hash. Again, we'll talk about that later, the name of the person doing the commit, and then the timestamp of when they did the commit. And Linus actually came back from the future to do this commit for us. So it's 2030 is the time that he did this. And you can see that actually the original version of this that had all those typos was from the same commit where Linus Torvalds did these other things. But because we went back through with our example and overwrote this line, it now says that it wasn't Linus Torvalds who's to blame for this line anymore. It's now Mike Isbicki who is to blame for this line. Yeah, so it wasn't actually Linus who made these commits, and he didn't actually come back from the future to do this. And so a lot of people think that all of this information that's stored in a Git repository, because it's on GitHub and because you need usernames and passwords to do things on GitHub, a lot of people kind of put trust in, we call this the history of the Git repository. This is one way to view the history of the Git repository over here. And a lot of people put a lot of trust in the history of Git repositories. But it turns out that anybody can make any commit under any person's name. I can commit as Linus Torvalds if I want. I can say that the date was from the future if I want. There's no guarantees that this history is actually correct. When you run the Git Commit Command, you can actually just specify what you want your username to be and what you want the time of the commit to be. And in order to figure out how to do that, we're going to introduce a new sort of tool for the command line called the man page. And the man page is the standard way for, man page is the standard way to get help about a tool. If you don't know how to use something, the first thing to, well, these days, the first thing to do is probably to Google your question. But if you don't get great Google results, or once you're a little bit more familiar with man pages might be a first result. These are like the ground source, ground truth of what can any tool actually do. It's the official documentation. And so I'm going to type man git commit, and it will bring up the official documentation for the Git commit program. And again, here I'm going to use the / key to do a search. So I'm really trying to ingrain in your head that you should never be scrolling through documents manually. You should always be using the / key and doing searches. Get in the habit of doing these things as fast and efficiently as possible. And what I want to search for is the word author, A-U-T-H-O-R. And we'll highlight all the locations in this document where author appears, and we'll keep going until we find the particular command line flag, which lets you specify what the author is. So it turns out if you do git commit -- author, you can make the author be whoever you want, or git commit -- date, make the date be whatever you want. So these are not secure. Git is not a secure system with this respect. All commands that are in the terminal have these man pages built in. So if you want, say, this ls command, you want to know the details about how to use it better, it's man ls. That brings up all of the options for how to use ls. Yeah, and so forth. Are there any questions about anything else so far? Anything at all?
I have a question.
Yeah, go ahead.
So when you're explaining how to, when the upstream is like ahead and you want to update the downstream, what if, I mean, the example that you used, they were all in, like initially the downstream had everything that the upstream had, but what if there was also some differences that the downstream had and the upstream didn't have? Do you have to merge first or something before?
Let's see. So in the example that I did, there was differences. There was contents that the upstream had that the downstream did not have.
Yeah, but the downstream had everything. No, the upstream had everything that the downstream had.
Okay, yeah. So one of the things that we haven't talked about with Git is merging things together, and it's very likely when you do a Git pull or a Git push that will result in you having to do a merge. That's something that in the lab it'll go through the steps of doing these Git merges. But yeah, so I guess the short answer to your question is that it's possible to have to do a Git merge on a Git pull.
Thanks.
Yeah, so that's content-wise for today. That's everything that we're going to talk about. That should set you up pretty well, I think, for doing the labs and the homework assignments. Again on so Friday from let's say 10 to 11 would be the lab time, and you're welcome to come and ask questions about whatever during then. Welcome to come and work on your project collaboratively. I think you'll find it easier doing it then than on your own, but if you can't come, it's not required. Both the lab and the homework are due on this Sunday, and but if you do come to the lab session, or if you can't come but you collaborate in any way open up a Zoom session with some other student from this class, then you get an extension until Tuesday on the assignments. Are there any questions about any of that sort of administrative stuff?
So how, like, are we supposed to mention something like we came to the lab if we submitted it?
No, so I'll be there, so I'll just have a note of everybody who's come, so I'll know whether it's whether you came to the lab or not came to the lab. If you were not able to come to the lab, but worked with somebody else, then just in your Sakai submission say, oh, I worked with whoever, and that'll be enough. I'll take your word for it.
Is the lab different from the homework, or are they the same thing?
Good question. Let's, so sharing my screen again, under week 0, the lab instructions are all right down here, and the homework instructions are, you click the homework link and the homework instructions are right here. They're closely related. They're both about working with Git in the terminal, but it'll be 2 different submissions on Sakai.
So every week we have a lab and a homework?
Every week there'll be a homework. Most weeks there'll be a lab, but possibly not all of them.
Okay, thanks.
Let's see. Yeah, we're over time, so I will stop class. Thank you all for being here. I'll see you either on Friday or next